Good evening, everyone. So, not yet. Good afternoon, I suppose. You're right. So, how is everyone doing? How's the conference so far? Yeah, welcome to Germany. How is the conference so far? Yay! Well, that was the Czech Republic. And how's the conference so far if we would have been in the US? Awesome, right?
I think the conference is terrific.
It's terrific. It's awesome. It's the best.
It's gonna be great.
So I've been to and Vacek has to go. So this is Vacek. We're gonna do the proper introduction in a second, but we always have to do this. Well, if he's around with me, he has to do these stupid things. But I was at a very big conference, and there was a huge crowd. Hello, say hello. Is it working? Kind of. Yeah. And he walked up to the stage and did the selfie thing, and it was really, really impressive. So I keep doing this now.
In case he made you confused, he was not talking about me. It was some other guy, like a famous guy doing this. So
yeah. Okay. Actually, this morning I realized my power plug was gone. Left it at home. So we're doing serverless, computerless today. I forgot my computer today.
I'm the container guy. I need a laptop. He is in cloud all the time.
Yeah. So yeah, these containers they keep slipping away, right? People had these containers, and now, like every year, they keep sinking. Nobody knows where they are. So. We didn't know when this talk was going to be, so we thought we might do it in the morning, and we had a hangover, or we might do it before the party. So this is our talk, basically. If you want to read it and get a beer, you're happy to leave. Otherwise, we're going to talk about it a little. We're going to talk about serverless, setting a little bit of the context and comparing it to containers. But before we start, I guess, and before we introduce ourselves, I guess one important thing is that I really like this conference because it's about technology. It's about coding, right? Stefan is one really good example of, like, you know, keep with the technology. At the same time, I feel sometimes it's a little bit humble. There's so many things going on, right? You know, I'm going to talk about serverless today, and being the serverless expert. That said, I'm looking at this technology for half a year now. I'm not the most expert in this, and I know that you guys are coming here for learning things, and you know, please do so. You know, and please look at things and don't be shy, embarrassed about learning new things. Learn them, get out there, talk to each other, because that's the fun part of our industry. And yeah, sometimes it's a little bit getting out of the comfort zone, but in the end, I find, at least here in Hamburg, a lot of friendly people approaching me. I can talk with them, even if I know that, like, technology-wise, they know so much more. So great new stuff, containers and serverless. So who's using containers in any way, kind of like more like, who's using containers? Yes. Who's using containers and like more than just playing around? Somewhere production and awesome. Not anymore. Right, here we go. So who uses serverless stuff? Okay, couple of hands. So I'll refer the questions to you. Okay. Let's start. Vacek, who are you?
Hello, I'm Vacek. I'm from Czech Republic, and I work for Red Hat for 5 years already. And for the last 4 years, I was working with containers. When Docker came around, we started to do things with that. Now we have a orchestration platform, OpenShift, and stuff like that. And we both work with the developer tools team, where we use OpenShift and we build new things on top of OpenShift. So that's what I do. I help people to get stuff into containers and then make it scalable. And yeah, that's what I do, I guess. And I like this conference. It's my first time, and the only person I know here is Matthias. So he's making it great for me by speaking German to people so that I don't understand a word. Thank you very much.
You're welcome. I'm the right guy. So Twitter handles. Yeah, I'm from Bonn, Germany. I also work for Red Hat now 1.5 years. Worked at several other startups within Germany. Now working for this huge enterprise in the US. But yeah, I guess the word we're trying to spread from a Red Hat perspective is containers, containers, containers. And our tool there, our offering is centered around OpenShift. I actually heard a couple of, in other talks already, people using OpenShift. So if you have any questions around there, please feel free. But that's the end of the commercial for nowadays. So this is DockerCon. So that's like 3 years ago.
Yeah.
2.5 years ago. And down there, that's Waszek and me. And back in the day, I was not working at Red Hat, but I was, I was trying to get into Red Hat, basically. I got introduced to Waszek.
You're welcome.
We immediately talked about technologies, solutions. Back in the day, it was containers. It was Atomic App, a version from Red Hat on how to cluster multiple containers together and build something bigger. It was Kubernetes-based, right? It
worked with Kubernetes, Swarm, OpenShift, Mesos.
Right. It was an abstraction around that, yeah. Right? And that was before Red Hat. Actually, we both always had heated discussions about technologies, always centered around containers. And this is also this talk, right? We're going to do a little bit like a divide between us two. So I'm like trying to be on the serverless camp, which I actually am, and Waszek is actually on the container camp. So we're not going to give one definitional guide to anything, but trying to compare it and look at from different sides on things.
I'd like to mention that you said we have heated discussions. We never agree on anything.
Right. Yeah, I was actually angry the other day at you. Yeah, I almost closed the call. Yeah. So let's see how we go for today. One important piece, I guess, and this topic is like huge, and there are so many opinions, so we need to, focus on something. And what we want to focus on today is the developer's mindset. And with a developer's mindset in a sense of an web application developer, right? So the standards back-end stuff that you would probably know. So we're not going to talk about desktop applications. We're not going to talk about like specifics to mobile, embedded. Typical web applications from a developer's mindset.
Okay, that's mine slide. It's beautiful. And basically, the thing is that when we talk about containers, there are two sides of things. One is the developer side or the development side, and one is the infrastructure. And what I'm trying to say here is that if Matthias gives me the next slide, I'm trying to say that the infrastructure is pretty easy. Everyone wants to use containers in infrastructure these days because it is like you can do anything, right? You can do like a VM thing. You can do microservices. You can do whatever you want with containers. And they kind of won the place. We don't think about VMs anymore. We think about containers. From the orchestration point of view, which is very important with containers because you don't run them somewhere in the wild without control. They sync, as Matthias said. Kubernetes won this competition or this fight. And you can see that from the members of Cloud Native Computing Foundation, which is looking at orchestration of cloud-native applications. And even Amazon joined recently, so mark my words, Kubernetes are coming to AWS. I'm not from Amazon, so I have no idea, I'm just guessing. So don't actually mark my words. Don't tweet it or anything. Generally, containers are great and awesome, and everyone loves them. So With that, we can go to another slide, and that says we are not going to talk about this part. So infrastructure is great for containers, and we will all use it, even if you don't know that, because they are used behind the serverless stuff. But we want to talk about development and look at the things from the developer's point of view. And I think it's your turn again.
Right. So I guess, it kind of in preparation for this talk, we already had the assumption that, most of you probably know containers. And if you have any questions, talk to that guy. He knows most of it. But there were a couple of hands going up with the serverless stuff, and I think it's worthwhile before we do the comparisons from a developer's point of view, to run through what serverless is actually about. So I know the first thing that you say, well, but there's still servers, duh. Right? It needs to run somewhere. So yes, let's not get down to that down that road. And yes, a lot of people are complaining about the term, but this is the term that's settled. I personally don't think that it's going to get changed. People always try it, and I'm confused even more. So the essence of it, and that's one quote, is that serverless is the trend of the absence of the server concept during software development or for a software developer. So as a software developer, I don't have a server that I'm explicitly thinking about, right? And you could think about this in very different abstractions. So here's a better, well thought through definition. And this is from the free ebook, which I can recommend reading if you want to read up on it. But from serverless in general, is first of all the idea that you just run small pieces of code, small functions. And that part is usually referred to as functions as a service, right? You have infrastructure as a service, platform as a service, and now you have functions as a service. So you can throw over a function, it runs, and that's all you know. You do this in different kind of languages. The usual one is Node.js, but it's out there for several other languages. Now, if you have all these small functions, they need to communicate. And the first thing you don't want to do is couple them. So event-driven is also essential to function as a service, right? You have small functions, and they're triggered by some event. The first one is probably an HTTP event through some API gateway. But in general, you want to throw events and listen to events and consume events. That's from the get-go, right? If you learn about serverless, that's the first thing you do. There's nothing else that you have to react to event. And the third one is actually quite interesting, personally, I think, and I've not thought about that in the beginning, is that this whole thing actually plays very well, or is very well attached to the idea of backend as a service. So backend as a service is something also that you have a service. And usually it's in the mobile space, it's more popular. The mobile backend as a service, MBaaS. But it's that you have some service which you just consume and you just pay for it in some sort of the fashion, and you don't run it. And it starts by infrastructure kind of types. So you have your database running, but it comes up in much higher abstraction levels, much more to user functions that you probably need as part of your application. So the canonical example in the serverless world is authentication, right? Authentication, and this is from the Auth0 guys. That's one part, and all the big vendors have their own authentication service. You don't need to build that again, right? You just consume it. So functions as a service, serverless, my definition, or this guy's definition, functions as a service, event-driven, BaaS. Now, the first thing that people come up with is what about the past, right, in this world, right? What about the Herokus or our OpenShift running on Kubernetes but does a lot of past stuff? Is that also serverless, right? Because many of the constraints before, or many of the definitions before, hold true here. And actually, one of the cloud gurus, Adrian Cockcroft, said, if your PaaS can efficiently start in instances in 20 milliseconds that run for half a second, then call it serverless, right? So there's some overlap, but to boil it down or really make it precise, I think these traits, if you run through these and define these, then you're talking about some serverless kind of architecture, platform, or service. And I want to run through these very shortly. The first one is, in a serverless platform, you have the trait that you don't manage a long-running server, container, or instance in any way, right? We just discussed about that before. It's like you cannot SSH into something and do something there. Now, with containers, you could not have an SSD daemon and to not enter it. So yes. But there's nothing running there that you can go to, right? Someone else takes care of that. The second trait is that it self-auto scales, self-auto provisions based on load, right? So as soon load comes, just these functions, fiddle around and just come up. There's nothing that you need to explicitly do, at least for the common patterns. The third one is actually pretty interesting, and I think many of the services that try to stick their serverless sticker on them, marketing sticker on it, are failing there. Is that it offers a cost based on precise usage, up, from, and down to 0 usage. If you write an service with serverless with functions as a service on AWS, well, they have the money to have you grant you a couple of invocations, many invocations. But if it's not invocated, if it's not run, you don't pay anything. If the function itself is just sitting or the function code is sitting somewhere, it's not loaded, you don't pay anything. But you pay by the invocations. Now, with serverless, with functions, it's time-based memory, but still, right? You don't pay anything. You don't have any subscription or anything, but it scales down to 0. And many self-proclaimed serverless are not using this. And I think this is very important, and we might go, well, we're not going to talk about this today. We can talk about it after tonight. I personally think it changes a lot. It can change a lot in our software industry because you now can build applications and only pay for them if they're actually getting used by user, which is mind-blowing in some kind of sense. Has performance capabilities defined others than host size and count, which is I shouldn't say the word obvious, but it's attached to the thing that we don't have a server, and has implicit high availability. Again, Mike Roberts, that guy, he wrote the blog post on serverless at Martin Fowler's blog. So this is how a probably typical serverless example looks like. That's my small pet application. So you have some Lambda functions, you have some S3 cache, you have some eventing mechanism. Again, here the user authentication, right? You have higher level services that you consume. You have some single page applications as a typical example of an serverless architecture. We can go through in the questions. We can go into the architecture, but that looks very typical. And this is a typical function how you'd write. Again, Node.js is the canonical.
Mm-hmm. Sorry. Okay. Don't look at it.
It's on video, Wojciech.
Yeah, well, then everyone knows when we have meetings. Damn it, where is my mouse?
In the open.
Where is the presentation?
In a serverless example, you write a small functions. You usually do Node.js, and you get an event context. You get some other parameters. You can act on it, and then you return. And
sorry, one more thing. I just close it, right? Okay, better. You didn't see this as either. It wasn't there. Sorry, Matthias. You can continue.
Yeah, I would.
Yeah, well, sure. What just happened? Don't.
Well, why don't you open the PDF?
Well, isn't that too easy?
That's too easy, yeah.
But then you need a laptop for that, and it's not cloud enough, right? Is it? Where are we?
That's too far.
Oh. So now you saw all the slides. You can go home.
Yeah. Yeah, the slides are up anyway afterwards. But typical example, right? You have some, you get some HTTP event. You get, the payload out of it. You transfer it. And in this example, I'm getting something from S3, so I'm calling something else. Again, I'm publishing in the event, hidden here in some utils function, and then returning some JSON payload. As far as I can tell, this is like a very typical, serverless example, very short. To close up the serverless introduction, there's a couple of providers. These are the big three currently. AWS Lambda. They basically introduced the concept. And we could go into detail why they did that, and Google and Azure followed, and especially Microsoft is pushing hard on them and bringing out new tools. So I've never been a C#.NET developer, right? Back in my days, Microsoft was evil. It's awesome.
C# is great.
C# is great. I like the language, but the company always seemed fishy to me back in the days. Now Microsoft is kind of cool, right? Bringing out cool new tools and things. So it's really great on the serverless front. They're from the developers' point of view, they're pushing a lot. So that's great. And we're from an open source company, right? It's not only just infrastructure in the cloud, and it's not the not the new mainframe that you get hooked into, and you have your perfect vendor lock-in, but there are open source alternatives. And here are a couple. But just recently, Apache OpenWhisk, which was started by IBM, Red Hat announced that we're collaborating on them and doing work on them. So in the open space, if you want to go down the serverless route in an open source fashion, there are some options. But how are we doing that with the container stuff?
Okay, I was going to blame Matthias for no time for questions, but then technology failed. So if there is no time for questions, it's my laptop's fault. I don't blame people. So what about containers? So Matthias introduced you to serverless. You now know what it is, and you probably go right after the talk to write some functions. If not, then you can look at containers. And what we did was we looked at the workflow. We have already said that containers are very versatile. We were trying to figure out some picture that would sum it up. There is no picture on Google like that, or we can't Google well enough, so no picture available. You can do basically a light VM, light virtual machine with containers. I don't really like that, but it is possible. You can do microservices, so you take your application, you split it up into multiple containers, you run it in an orchestrated manner, and things communicate automatically, and that's a lot of magic and voodoo and stuff like that. Or you can even do things like function as a service with containers, like you saw the OpenWhisk stuff. Matthias mentioned OpenWhisk stuff, which runs on Docker containers and can actually run Docker containers similarly as functions, or it runs them as functions. But the thing is that unlike functions, which will always be kind of small unless you want to pay a lot of money and be very unproductive, containers can grow huge. Have you ever tried to put some Java application into container? I have had like 3.5 gigabyte container last week. So they can grow huge, and that's a big difference from functions. But we wanted to look at developers' workflow. And compare it between these two technologies. So if you think about developer, what we do, who is developer here? Who is not developer here? Okay. That's a lot of developers. So we basically write code. I draw this, right? So don't take pictures. We write code, we build it, we run it. Sometimes we test it, and most of the time we deploy it. So let's go through this and then talk about the specific stages of development workflow and go a bit into detail. So we were thinking about like writing the code. What is the difference between writing the code for containers and writing the code for functions? If you think about it, what you do is you pick an IDE. Some Vim and Emacs fans? Okay, yeah, you can have fight outside. But I like Visual Studio Code recently because it is web-based, very slow, and it's from Microsoft. So I use it for writing my Docker files and YAML files for OpenShift. But there are some interesting links which are almost, you can almost see them. I have no idea what happened there. But basically, you can build containers with Visual Studio Code. I mean, it still will use Docker or something, but you can have plugins that will help you just click one button and do stuff. You can debug functions, debug serverless with Visual Studio Code and run it on the background, some mocking stuff. But basically, the writing your code will be the same for both. You will use different libraries, maybe different language, but it will look almost the same. Then next step is build, right? So how do you build container? There is many ways. The basic way, which is the most complicated and most awful, is Dockerfile. And basically, you annotate a script and make it look fancy because it's something file, so it's Dockerfile, hipster thing. Or you can use something more sophisticated, like source to image, where you just take your code, you say this is Python 3. I don't know what is the latest version, and build it, please. And it will automatically take the code, install dependencies, put it in the right place, make there an entry point so that the container can start with your code starting and stuff like that. And it works for Java, for Golang, for many things. Then there is Ansible container, which I would say, I don't know Ansible much, but I would say that that's how our ops guys would use containers, right? How build containers. But you can define in the playbooks how to build your container and what should be inside and stuff like that. And then there is something called Draft, and it's from the guys from Days. They were acquired by Microsoft. We can't get out of mentioning Microsoft. So a Draft is something like source to image, but it's a bit smarter and probably will break easier. But it can guess what language are you writing in, and it can generate the Docker file for you, and everything will work awesomely. I've tried examples. I haven't tried to do something to break it, but it seemed to work for the examples. And for serverless, it's very easy. You just zip it and send it to the cloud, right? Not really true, because for Java and Golang, basically all the compiled languages, you need to compile your binary first. You need to get some artifact like jar or Golang binary, then zip it and send it. Or Matthias claimed that you don't have to zip it, but everyone mentions zip. It's a great tool. But it is easy, right? But if you think about it, you can take source to image, and you can take the zipping, and it will be basically the same level. Running. I like to, who is a runner here? Never mind. So for containers, if you want to run a container, single container, you can just use Docker run, or you can use Docker compose, and it's very easy. If you want to run a whole application and you have Kubernetes or OpenShift configs ready, you can do OC cluster up, so OpenShift cluster up on your local machine and run your whole application on a single machine. We are running a service, OpenShift.io, and it takes just 9 GB of your memory. So if you have a laptop like me, you are missing 1 GB. But it's great. You can run everything locally. With serverless, it is a bit more hard because you are using these backend as a service, right? Or these backend services. So running it locally is hard. You can run a single function, but running whole application, there is something like serverless offline that will mock like DynamoDB and will mock some other things. And it will work for simple use cases. There is Azure local, And you can run OpenWhisk. If you develop your serverless functions for OpenWhisk, you can run it on top of OpenShift. So you just do OC cluster up, run OpenWhisk on top of that, and then your memory is gone. But you can do it. The thing is that even for containers, same as serverless, if you do things properly, you probably will not run your database in container. You will probably take some RDS in Amazon or something else, some other backend service, and you will use that as a database. So if you do that, then all this is nonsense because, well, you can connect it to the Amazon cloud and send data there, but it's going to cost you money and it will be slower. So it's always, you either have to do everything locally or you will have some pains. Testing is a bit of hard thing to talk about because I don't know much about testing. Matthias Snyder, he wrote this application for Amazon Lambda and he has no tests, I think, correct?
No
so
tests.
we have no idea how to write tests. But what we think is that there is couple kinds of tests, right? There is unit tests, integration tests, acceptance tests, and some of them you can run locally, some of them you can run remotely, or you have to run remotely. Basically, what we, I think, said here, maybe not, but it's in comments, in notes, if you do unit tests, it's fine, you can run them locally. If you do integration tests with serverless, you will already do it on something like production-like environment. So you will spin up a new serverless namespace in your Amazon Lambda, maybe, and deploy your functions there, and then you do some integration tests. If you do it with containers, you can still run 2 containers and check whether the API contracts are fine or not. For acceptance tests, which is like how your user sees your system, you will want to run it on production-like environment anyway. So that's same for containers and for serverless, because you will have to have production and staging environment, and then you deploy it there, the new version, and you run the acceptance test, and you figure out that something broke, and you need to whatever. But you will do it the same way in the cloud, on your cluster, whatever. There are some interesting articles about unit testing and how unit tests are useless. So you can read it. One of those articles Matthias sent, so I had to put there another which is not agreeing with it. But the word automated is very important there, because you want to automate as much as possible, which gets me to deployment, and you want to use some CI/CD, so you don't actually do any of these things. It just works. Not true. But yes, that's what you want to try. With containers, if you are deploying containers, you will probably use some orchestration like Kubernetes, OpenShift, Mesos, Docker Swarm, and they all have some specific formats for describing your application. Like OpenShift and Kubernetes use JSON and YAML, Swarm different DSL in the YAML. I don't know about Mesos, but basically, you describe your application and you already have it built, potentially tested, and you just apply these configurations and it runs. For serverless, you can click everything in the UI, which is what I saw Matthias doing all the time. He loves web UIs. No, that's not true, because Matthias uses Apex, which is one of the frameworks that allow you to automate your deployments. And serverless is like the most famous, probably. I have found now, and Matthias was like, what is that? I'm like, I don't know, I just found it, and it said serverless, so I put it there. And Matthias said that Apex is great, and I think they get some money or something, right? He said.
Apex, the nice thing about Apex, it's a very concise, small framework. Serverless is also a great framework because it does abstractions of a lot of technologies, so you can theoretically, move between different infrastructure providers. I think we're a little bit early in that stage, so I like to focus myself on one provider. And Apex currently just does AWS, but that's fine, and it's a very small, tiny tool.
Cool. But you can automate things with these frameworks, and that is the goal for deployments and for getting from some local to staging to production. You don't want to do it manually, and it's same for both. Basically, what is the summary of this workflow, this comparison? It is that if you stick with good tooling and with the right tooling and doing things in a simple way, you get very similar workflows. From the developer point of view, how you write your stuff, how you build it, how you deploy it, that's just different tooling, but the steps and the amount of work done will be very similar. The problem, or maybe it's not a problem, maybe it's just a feature, is that with containers, you get many different use cases, and you can, like I would say that microservices, when you use containers for microservices, it's closest to functions as you can get. So that's like I'm using all the cool stuff like source to image, and I deploy to OpenShift. It scales automatically and things like that. And it's like functions, right? But then you can do IoT, which will limit you a bit more. And then you can do something like system services, which runs your DHC client in container. And that's like, why? But you can do it with containers. And what I'm trying to say with this is that containers are so flexible that even if I describe the workflow, you can always find some advanced functions you cannot do them with serverless. They will allow you to do it with containers. But I lost my thread. Never mind. Anyway, containers, you can get advanced functions, and you can get much more complicated workflow than with serverless, and serverless is pretty restricted with that. Whew.
I love that. I love that picture because it's so much IT there, right? You know, just one great hammer isn't enough, right? You always want the best, the other hammer, the better hammer. I actually like hammers themselves, but you know, I know that for myself. When I started using containers and learned containers, it was the best, the best tooling I have. And now I'm down that serverless route, and there's all these containers are gone, and everything is taken away from me, right? I just have this simple hammer, and I don't have this versatile tooling, and it's hard.
That's exactly what I wanted to say.
So
Thank you.
So developers' workflow is I guess an important topic for us. It's the tooling and the others. A couple of other considerations that while you approach this containers versus serverless thing. One thing is that it a little bit goes into, we talked about that a little bit, but you need to make sure that in the serverless world, while a lot of people are using it for more and more things, it's still very opinionated, right? You have ephemeral application logic, right? That's sometimes hard to get into your mind and into your applications. So you need to have some backing services there, and everything is distributed. Right? I don't know who said that, but some Microsoft microservices guru said, if you're not capable of running a monolith, how can you think about that you're capable of running a microservices distributed applications? So think about that first, right? Everything is distributed. It starts, it gets mind blowing. Now, we said that we can do this all with container technologies, and we do have limitations, right? It's not the universal platform from the compute perspective for everything, right? If you have some very CPU, or you need a special CPU, special architecture, CPU architecture, you cannot do serverless, right? At this point, the vendors don't provide that. If you need no latency between these functions, they're distributed, right? Don't do it. So it is very limited. The point is that this might be actually a feature and not a bug. The other thing, and stating the obvious again, this is control versus managed. Are you ready to give up your control to the big American vendors, or do you want a control of it? Yes. There are open source solutions, but they're not as mature as the others, and they don't provide the full set of features that they have, that the others have. And the other one is, that's like our big claim: containers are just Linux. That's like you cannot have a more mature technology as containers, actually, right? Yes, this Docker format and all these things and Kubernetes is new, but the basics the underlying infrastructure is so well known and so mature. So, you know, think about it before you jump on the new bandwagon. Anyway, we wanted to get have some opinions around this. You know, basically comparing these two and you know, getting there. But we have some opinions, and it started with me, you know, fooling around with serverless, and you know, there's something that I would like to encourage you thinking about is, you know, the idea, the mind shift you get by using serverless is once you get into it, is actually mind-blowing. The idea that there's no service, that you just run some functions, is actually makes you think differently. Yes, everything is distributed, and this event thing was actually new to me, but once you get used to it, it actually feels very natural. It very feels like, it's like, you know, people are getting into JavaScript, and they suddenly realize it makes sense that there's always some event getting triggered. And similar in this fashion. And it's different than the paradigm that I used before, but it's actually, once there, it's actually pretty interesting. And once you're in there, you also realize, and you start consuming APIs, you suddenly realize, like, okay, maybe this functionality is an API, because you know, and you consume so many APIs that you only think in APIs. And when you think about APIs, any good architect would say, well, great, right? You're suddenly figuring out a context, a boundary. You're suddenly modularizing your code, and you're thinking of services. And I think this is like the perfect example down the microservices route, right? You start thinking, at least I start thinking in services, start thinking in APIs, and I think that you know, at least, you know, from that's how I experienced developing on it.
Matthias, 2 minutes.
Mm-hmm.
We have 2 minutes.
Well,
yeah.
It's so great.
Yeah, the flow. Do you feel the flow?
So I think you know, the important part for me was the amount of things that I was able to do as a single developer. Yes, I used many of the other backing services, but I could produce so much. I just had this one hammer, but it was kind of a big hammer.
Okay, my turn. So my quote here is, containers give you freedom. I had a containers give you headache, but Matthias forbidden me to put it there. But they give you freedom. You can do whatever you want with them, which might be good or bad. If you are developing something for IoT or embedded devices, or you just need some GPU stuff, because you do some machine learning, you can do it with containers. You can't really do it with serverless. Have you ever given freedom to developers? It always ends well, right? You need to think on scale, because the problem is that containers don't force you in that. Serverless does, but you need to force yourself to think in scale, like this container will run 100 times at the same time, and they need to somehow distribute the work, right? And they need to not collide in database or in S3 or in some storage or something, right? The main part of containers is the orchestration. Because you can write a great container, well, you can create a great container with great application, but if you cannot orchestrate it, you can run it, you cannot keep it alive, then it's worthless. And it's just work you did, and it's useless and stuff like that. The thing we had an argument about is whether function as a service or serverless needs operations, like ops guys that would sit somewhere and fix things in infrastructure and stuff like that. Because infrastructure is given by some vendor. In containers, this doesn't go away because the orchestrator needs to be managed by someone. You can buy some stuff from some vendor, like Red Hat, OpenShift stuff, right? But it still needs some operations guys that will sit there. For serverless, it's kind of different because they will do different tasks, but they will still probably be there. At least that's what Matthias says. I have no idea. So with containers, Matthias said serverless is fun. I'm saying it was fun for the last 3 years. Now it's just work because things are kind of stable and working, and you have a lot of people that do containers in production. So it's there, and you can just use it. You don't have to play around with things and try things and hope that it will work. that you will be able to debug it and find logs and stuff like that in the ugly AWS console. I never can find anything there. With containers, it's like, it's there. We are just using it. I don't know, what's our next slide?
So I guess we're going to jump over it just a little bit, but there is OpenWhisk. We're getting it running on OpenShift currently. Expect something down this year to play around with. So it's actually there's an at some point in the future you can actually have both.
The thing what Matthias wanted to say also is that OpenWhisk, maybe it's here, right? But OpenWhisk is like any other serverless platform where you can run your native languages or compiled languages, but you just deploy your function. But you can also wrap your code inside a Docker container directly and then run the container as a function. So if you have some crazy C code that touches some peripheral devices on your server, it's not really serverless, but you can run it as a serverless with OpenWhisk. That is the point of, like from my point of view as a container guy, that's the main feature of OpenWhisk, that I don't have to rely on this new function as a service stuff that I don't trust at all. Yeah.
So this is the too long didn't read. Thank you for staying as long, but this is the summary. Serverless is function as a service event and backend serverless. With containers, you can see similar characteristics, right? If you build your tooling, you can get pretty near there. Containers are much more versatile. They enable different architectures. And by the way, you're running containers anyway, right? So we are in Red Hat. We are always happy. But think about serverless. It's an opinionated architecture, but sometimes these opinions make sense. My experience is that you start writing on that you start focusing on application logic and your application design, the precise cost-based usage pricing is actually going to change a lot down the road. Here you can mark my words, which are not my words, but from some strategist. But there's a lot of things coming down. Yeah, so I think, do we have time for questions?
We have a time for half of the question.
We have time for half of the questions. Otherwise, please see us here and go to this website.
So you can ask question, and we will not answer it because we don't have time for that.
No.
No? Okay.
Yeah, interesting talk. I just want to know generally about this function architecture. Do you have experience with multi-layered function as a service thing? So I imagine the typical use case is a user submits some web request and then the function triggers off and does something. But what if the user event triggers a function inserting some data in a database, which triggers functions, which update, I don't know, marketing, distribution, purchase, whatever service, which all display back on the user interface. Is it there?
Right.
Is it useful?
So I'm trying to rephrase it, or trying to get the question is you're basically saying, like, if there's a single event and there's something happening and we're returning something, that is like, well, kind of like makes sense. Do we have experience about like fanning out different events, getting to other services, consuming them and putting them back? I personally don't, but there are a couple of companies that run everything in Lambda. As I said before, it's very early on, so a lot of tooling needs to be done. But there's tooling on the different vendor side to group functions, to chain functions, so that you can lay them out. So the event decoupling, you can visualize them and see which event goes where and how to connect these. So there's tooling there. How good it is, some say, don't go that road, it's too complicated and it introduces more complexity. I don't have any experiences. At this point, the industry is reaching out, right? The serverless framework just got funding. We are in that area are just trying to find the best practices. We don't know yet.
And I would like to comment, and that's like from conceptual point of view, exactly as you described. That's the serverless architecture from my point of view.
Right, decoupling via events and consuming them. But what is the tooling around it? How would you do it? Yeah.
Any other question that we don't have time for? No questions. Great. Thank you very much. Find us.
Yeah. Thank you very much. See you tonight and have a great conference.